start. We have main engine start. 4, 3, 2, 1, 0, and liftoff. The liftoff of the space.
In our natural pursuit of knowledge, space has always mystified and beguiled us. Over the past 5 decades, we've pushed the final frontier inevitably onward into the ether. The cost has been colossal. Now every day, new data, new conclusions, and the thirst for deeper exploration propel us inexorably onward. The advantages of the discoveries made through space travel are myriad, but the fundamental curiosity as to what is out there will always fascinate and taunt us. Come with us now into the unknown and discover the disappearing frontier. In this edition of Disappearing Frontier, we reflect back on the early 70s, which began with a total solar eclipse, an event of such magnitude that it won't occur again until the year 2024. 2 TIROS operational weather satellites were launched in 1970. Their task was to look at the Earth's cloud cover and return daily weather information. Nimbus, an advanced weather research satellite, was placed into orbit, and soon after that, 2 communication satellites were successfully launched as well, as part of a global communication system. In the field of aeronautics, NASA continued its research in wake turbulence. These smoke tower tests showed how tornado-like patterns of air are churned up as a large plane passes by, causing potential hazards for lighter aircraft. NASA's Earth Resources planes took high-altitude pictures of Peru's devastating earthquake, photos that contributed to the remote sensing of future natural disasters. They also made temperature and colour measurements over the tuna-rich fishing grounds near Oregon in an effort to assist Pacific coast fishing fleets to increase their hauls. The space program hit a setback in 1970 when the 3rd manned lunar landing attempt was cancelled when an oxygen tank erupted. The Apollo 13 astronauts, Lovell, Hayes and Swigert, were safely recovered from the Pacific Ocean on April 17. Trying out life support systems for long-duration space flights of the future, 4 college students from California spent 90 days confined in a space station simulator. The crew drank water and breathed oxygen reclaimed from their body waste and emerged after their confinement showing no apparent effects. Beginning October 18, Soviet cosmonauts Andrei Nikolaev and Vitaly Sevastyanov toured the US and several NASA field centers. During that same month, the United States and the Soviet Union agreed to study ways that the American and Russian spaceships could meet and join in space. By 1971, 3 Mariner spacecraft had flown by Mars for fleeting glimpses of the mysterious red planet. The closest of these passes came within 2,000 miles of the Martian surface. On November the 13th, 1971, Mariner 9 changed all that. As its braking rocket fired, the picture-taking Mariner swung into orbit around Mars, an orbit which allowed the spacecraft to come within 850 miles of the surface. As it circled the planet twice a day, it photographed and gathered data and eventually mapped 70% of the planet's surface. The 2 small moons of Mars, Phobos and Deimos, were also closely scrutinized. Information gathered by Mariner 9 showed that Mars had gone through some type of planetary evolution. The main question was whether it was an evolving planet or a decaying one. Mars was found to be more Earth-like than any other planet. Its clouds, seasonal changes, and polar ice caps still intrigue scientists today. As the most powerful computers of the day whirred into action, NASA waited nervously for the first pictures to arrive, in the hopes of answering some of the questions that have puzzled mankind for centuries. The Sun is roughly 10,000 times larger than the Earth. Its very presence affects our daily lives. To learn more about this and how it affects our environment, NASA orbited 3 unmanned scientific explorers. IMP, or Interplanetary Monitoring Platform, was the first. The versatile IMP, 8th in a series, explored inner planetary space and the fringes of the Earth's magnetosphere. It also provided warnings of possible solar flare radiation hazards to moon-bound astronauts. With the Naval Research Laboratory, NASA launched the SOLRAD satellite. It too studied the sun's radiation and recorded the disturbances which could disrupt long-range communication and navigation systems. This computer imaging graph shows the sun's disk and inner corona. It was returned by OSO 7, the most advanced solar observer of its day. OSO was trying to determine the direct effect that solar flares had on the environment, weather and communications. Earth is surrounded by the magnetosphere, an enormous teardrop-shaped region formed by the solar wind, a supersonic stream of particles flowing on the Earth's magnetic field. It's in this region that a craft like this small scientific satellite did its job. Its mission was to investigate the causes of worldwide magnetic disturbances and map in detail the ways in which the motion of these particles changes with time. Later that year, Stratoscope 2, a large astronomical telescope, was hoisted into the sky by a giant balloon from the Marshall Space Flight Center in Huntsville, Alabama. This was the 8th Stratoscope flight. Its goal? Obtain sharper pictures of certain galaxies, nebulae and the planet Saturn above the distortion of the Earth's atmosphere. The 4-ton telescope was so advanced for its time, it could distinguish two objects 30 miles apart from 1,000 miles away. And scientists worked on the data it returned for several months following each flight. In the field of avionics, NASA used planes like this in checking out cameras and sensing equipment to be carried on future Earth Resources satellites and on the manned orbiting Skylab space station. An interesting side benefit took place that summer, as the specially equipped planes were used to detect southern corn blight during the growing season. High-altitude infrared photos were taken and then analysed by Purdue University and the Department of Agriculture. These photographs were used to determine the extent and degree of corn blight. At the request of the local government, survey missions were flown over the island of Jamaica. Much of the water from Jamaica's 200 inches of rainfall never reached its cities. It was believed that submarine springs carried a portion of the water offshore into the ocean. This was indicated by the preliminary analysis. This jet was one of a pair of high-altitude planes, converted for use in Earth resource surveys. They operated from NASA's Research Center near San Francisco. The data collected by these flights was used to simulate future remote sensing Earth resources satellites. Satellites that will be used to study agriculture, forestry, geology, oceanography, and urban development. Test pilots at NASA's Flight Research Center in California flew a plane with a new type of wing for the first time in 1971. Called the supercritical wing, it's shaped quite differently from conventional wings. The new design alters the flow of air over the top of the wing, allowing an aircraft to fly faster, further, and at a lower operating cost. This sleek black YF-12 made 25 test flights in 1971. The Joint NASA-Air Force program studied problems associated with propulsion, in-flight stopping and restarting of engines, heating and structural dynamics. The researchers aimed at furthering the development and operations of future civil and military aircraft. The M2 lifting body was carried aloft 8 times in 1971 and dropped over the Dry Lake Desert in central California. The wingless M2 and other lifting body types were the research forerunners of craft like the proposed shuttle that could fly a space mission and then return through the Earth's atmosphere and land like an aeroplane. A new flight program began at NASA's Ames Research Center with the X-14B vertical takeoff and landing plane. Equipped with an onboard digital computer, the X-14 served as a flying flight simulator by duplicating in advance the piloting qualities of newly proposed planes. The Ames Center was also responsible for doing research on sharp takeoff and landing aircraft. this was one of the planes used to test new concepts, the OV-10A Bronco. At the time, the United States was very interested in developing a short takeoff and landing plane for use as inner-city transport in the nation's busy metropolitan air corridors. Attacking the jet noise problem at its source, engineers at the Lewis Research Center in Cleveland supervised tests of a quieter jet engine. The goal was to develop an engine that would be 15 to 20 decibels quieter than the noisy engines of the day. The scene is Cape Canaveral, Friday, May the 5th, 1961. It was on this date that astronaut Alan B. Shepard became the first American to be rocketed into space. Ten years later, January the 31st, 1971, Alan B. Shepard made his second spaceflight, this time as commander of Apollo 14, the country's third moon landing. With astronauts Mitchell and Roosa accompanying Shepard, Apollo 14 marked the beginning of large-scale use of the moon for science. These are some of the 94 pounds of lunar rocks that were returned from the moon's ancient hills by Apollo 14. They were just beginning to tell scientists their story, a story 3.5 billion years old. From them, we learnt about the early history of not only the moon, but other planets as well, the Earth, Mars, even Venus and Mercury. This was the view seen by Apollo 15 astronauts Scott and Irwin as their spacecraft Falcon descended towards the foothills of the moon's Apennine Mountains.
8 feet minus 1. Contact. Man. Okay, Houston, the Falcon is on the plane at Hadley. Roger, roger, Falcon.
Theirs was to be the most expensive exploration of the moon ever made. To prepare for the July mission, Scott and Irwin practiced on similar Earth terrain at the Rio Grande Gorge in New Mexico. They also spent many hours getting used to the lunar rover. Here's what it actually looked like to the Moonriders as they drove their four-wheel buggy over 16 miles of lunar surface. As a result of their increased mobility, the pair returned 180 pounds of lunar rocks and deep core samples. After liftoff and while still in lunar orbit, the trio launched a small scientific satellite called a subsatellite to study the area around the moon. As they headed earthward, astronaut Al Worden climbed outside the spacecraft and retrieved film from a pair of mapping cameras. The scientific instruments left by Apollo 15 and the samples they returned gave us a real understanding of the moon and its relationship to both the Earth and the Sun. One of the hottest topics in 1971 was the soon-to-be-launched Skylab, America's first space station, which heralded a new era of scientific exploration. According to Dale Myers, NASA's director of manned spaceflight at the time, Skylab gave us the opportunity to learn more about man's capability to work and live in space. And it's a quest that we're still on 3 decades later. By 1972, the mysterious red planet wasn't quite as puzzling as it used to be, thanks to the Mariner 9 spacecraft, which was sent up a year earlier. Mariner 9 orbited the planet continuously for more than half a Martian year, probing, sensing and photographing as the seasons changed below. To date, scientists knew that Mars had been geologically active with volcanic mountains. There were also indications that free-flowing water had existed sometime in the planet's history. Observed from above were huge impact craters and wind-blown dunes. The more than 7,000 pictures returned by Mariner enables scientists to map the entire Martian surface and pinpoint landing sites for the unmanned Viking mission, which was scheduled to soft land there in 1976. Jupiter, 1,000 times larger than Earth, distinguished by glowing yellow, orange and blue-grey stripes. It appears to have its own internal energy source and is so massive that it's almost a small star. In 1972, NASA launched the Pioneer 10 spacecraft towards the largest planet in our solar system. It was scheduled to fly by Jupiter in 1973 and take the first pictures ever recorded at such a close range. This is what the orbiting astronomical observatory named Copernicus looked like before it was launched in August 1972. Equipped with sensitive precision instruments, including a 32-inch diameter telescope, the heaviest unmanned spacecraft of its time was designed to study stars and galaxies to gain a better understanding of how they evolve and eventually die. Placed in orbit above the Earth's distorting atmosphere, Copernicus had a clear view of the stars and returned important new information to the astronomers every day. In cooperation with the Italian government, NASA orbited another in the Explorer series of spacecraft. The small astronomy satellite was launched from a platform in the Indian Ocean to study Earth-Sun interactions and especially search for gamma-ray sources. The same year also saw the launch of 84 sounding rockets with payloads to study phenomena affecting the Earth's atmosphere. These small, relatively inexpensive rockets taught us a great deal about near-Earth space, below the region where satellites orbit. A comprehensive program to make better use of the Earth's resources was in full swing by this time. High-altitude planes and the new Earth's Resources satellite were returning thousands of high-quality pictures of the Earth. As a result, scientists were hoping to better understand our own planet, its forests, crops, geology and pollution. The new Nimbus Research and Development Weather Satellite began taking the first vertical temperature readings from space through clouds. It was also monitoring a mysterious disappearing current off the west coast of South America and thermally mapping the Earth's surface so geologists could better understand what's occurring below the crust. 2 new commercial satellites were launched for the Communications Satellite Corporation. Adding new telephone and television channels, both craft became part of the growing global communications satellite network. The A in NASA stands for aeronautics, and in 1972 there were plenty of projects happening in that very field. For example, this airplane was equipped with a digital computer that was developed for the flight control system of the Apollo lunar lander. Its use in the planes of the future would make for smoother, safer air travel. Many aeronautical problems were being studied in NASA wind tunnels without having to test full-size planes. Engineers could test a tail or wing section to destruction and know in advance where structural weaknesses were before the first new plane was even off the drawing board. To help relieve airport congestion, NASA was continuing its short takeoff and landing program with planes like this. STOL planes, as they're called, needed very little runway to take off or land, and they played an important role in providing convenient, short-haul, inner-city transportation. This year, the wingless M2 lifting body was dropped 14 times over the Dry Lake Desert near the Flight Research Center in California. Craft like the M2 were bringing NASA's hopes closer for a reusable space shuttle that would fly missions and return to Earth, landing like an aeroplane. During his visit to Russia, President Nixon signed an agreement with Chairman Kosygin of the USSR to conduct an Earth orbital rendezvous and docking by 1975 between US and Russian spacecraft. Engineers from both countries were already working out the mission details. To help pave the way for the longest Skylab mission to date, astronauts Crippen, Thornton and Bobko spent 56 days locked in a 24-foot-long altitude chamber at the Manned Spacecraft Center in Houston. The purpose was to gather medical data which could be compared with that collected from the real Skylab flights. Skylab crew training and spacecraft assembly and testing was also well underway. Skylab itself was intended to be a space platform which could be used to study the Sun, the Earth, and our own limitations. Apollo 16 with astronauts Young, Mattingly and Duke, and Apollo 17 with astronauts Cernan, Evans and Schmidt marked the 5th and 6th times that mankind landed on the Moon. These two flights also concluded the Apollo program. But as astronaut Eugene Cernan said before Apollo 17, it's not the end, but the beginning. (1973). This was the year of Skylab, even though it got off to a shaky start when a heat-deflecting micrometeoroid shield was ripped off during launch, causing the loss of one solar wing and the jamming of another. Although in orbit, the big space station was overheating and low on power. People on the ground, however, hastily designed a replacement, umbrella-like device which would protect the workshop's thin skin from the hot sun. The first crew then used the newly designed sunshade to repair the overheating space station. They also deployed the jammed solar wing. The result, an increase in electrical power and a cooler place to work. And work they did. Many separate crews lived in Skylab for extended periods of time, proving that man could withstand prolonged weightlessness. And by training Skylab's onboard telescopes towards the Sun, the science of solar astronomy was extended beyond the limits of Earth-based observations. We were suddenly learning more about the Sun than ever before, gleaning information that may someday help us to use this giant furnace as a means of generating and controlling energy for use on Earth. Using cameras and remote sensors, the crews accumulated hours and hours of intense observations of the Earth. Observations that have ranged from taking measurements of hurricanes over the Atlantic Ocean to photographing possible new mineral deposits in Nevada. By the time Skylab came crashing to Earth, well over 42,000 pictures of the Earth's surface had been taken. They called her Arabella, the Space Spider. Actually, Arabella was just one of many student experiments aboard Skylab. The question raised by a young high school student from Massachusetts was, can a spider spin a web in the absence of gravity? The answer, as you can see, was yes, and led to other creatures being carried into space. This Buck Rogers-like rocket pack was also tested, and was the forerunner of equipment that's used on extended spacewalks today. American astronauts and Soviet cosmonauts began training for the proposed joint space mission scheduled for 1975. The two crews planned to meet and join their spacecraft while in orbit around the Earth. Beyond the rescue capabilities they would demonstrate, it was hoped the complex project would also lead to many international cooperative programs in the future. That brings us to the end of this edition. We look forward to your company next time. But remember, we are out there. What we can and can't see is out there, and the mysteries between us, although seemingly insurmountable, are encompassed by a disappearing frontier.